Hello class. Today we're going to continue on with our chapter 4 condensed notes, and this is going to be considered part 2. So what we're going to talk about today is distinguishing among atoms, and specifically we're going to focus on if I gave you certain values, could you tell me how many protons, neutrons, and electrons that an atom has? A couple of things to note before discussing these different types of atoms is one, we have to remember that an element is made up of only one type of atom. So for example, if I said you had oxygen as an element, it is only made up of oxygen atoms. If you had copper as an element, it is only made up of copper atoms. We also have to understand from the last lesson is that atoms are made up of 3 different types of subatomic particles. Again, those 3 types are protons, electrons, and neutrons, and each of them carry a distinct charge. Protons will always be positive, electrons will always be negative, and neutrons have no charge. And you might ask yourself, on part 3, atoms are considered electrically neutral, which means atoms have no charge. And you might ask yourself, how could this be? If atoms have positively charged things and negatively charged things in it, why is it not positive and why is atoms not negative? And the reason for this is because the positive charge in an atom and the negative charge in an atom actually equal each other and balance each other out. So I'm going to go ahead and start this. This is a big concept that we have to remember when we do problems in this section. Protons, positive, will equal your negative. It's kind of like if you had 3 protons, so that's a positive 3, and then you had 3 electrons, so that's a negative 3. Well, 3 minus 3 gives me 0. So again, they balance each other out. While finding the number of protons, neutrons, and electrons, there also has to be another number that we understand, and that is the atomic number. Elements are actually different because they are made up of different number of protons. That's what distinguishes them. And an element's atomic number is actually defined as the number of protons in the nucleus of that atom. For example, if your atomic number was 6, that means your number of protons was 6. Because atomic number, and I'm going to go ahead and start this as well, equals the number of protons. Like we said above, atomic number identifies that element. So if you change the atomic number, you're going to change the element. Again, if you change the atomic number, you are changing the element. The atomic number is actually kind of awesome because it can be found on all periodic tables, as long as you remember where to look. So I actually took a snippet down here of the periodic table that I hand out to my students in class, and for this one, our atomic number is right here in the top left-hand corner, and the number is 6. In the big one that I have in class, it's in the top right-hand corner and it's blue, but I give everyone this one, so I want to make sure that you guys know where it's at. It's also labeled. You have a key on this as well, and that's where I took this little snippet picture from. One thing to know about the atomic number is since it distinguishes an atom, the atomic number will never change for an element. For example, this is carbon. It says the atomic number is 6. It will always be 6 if it is carbon. If it was hydrogen, the number would always be 1. If it was helium, the number would always be 2. Each element gets a specific number. It's kind of like when I give you caddy numbers. That is your number and it's nobody else's in the class. The other type of number we have to understand is mass number. Mass number is actually the total number of protons and neutrons in an atom. Because remember, protons and neutrons provide most of the mass in an atom. Electrons are itty bitty tiny. So we call this mass number because it takes the 2 big things that have the most mass. Again, if I asked you to find the mass number, you would take your number of protons plus your number of neutrons, and that's what's going to give you your mass number. So I'm going to actually star this one. That should be the 3rd thing that I have starred or highlighted. Now, why do we care about this mass number? Well, we care about this mass number is because it actually helps us find the number of neutrons in an atom. So the way you find them is you can find the number of, this is a typo, so please cross that out. This is supposed to say neutrons, so make sure your note says neutrons there. And you do this by subtracting your mass number from your atomic number or your number of protons. So again, mass number minus your atomic number will actually give you your neutrons. Again, make sure that you change that in your notes. And this is going to be the fourth thing that I have starred. Because if I gave you something like that, we are going to use those 4 pieces of information to help us identify subatomic particles. In order to do this, you will always need a periodic table, and I will always provide you with a periodic table. The first thing that you're going to do on your periodic table is you're going to fill in the element name or symbol if you know them. So this one says that it is strontium. So if you go to the periodic table, strontium is right here. My symbol is Sr, so that is what I'm going to fill out here. Once you find the element name or symbol, you can actually find the atomic number by looking on this periodic table. Remember, atomic number is always found on the periodic table, so we're going to make that note. On periodic table, and that's actually really hard to see, so we're going to actually draw a little line. On periodic table. So if we go to strontium, we're going to see that its number is 38. So if I look at its atomic number, it is 38. Now, how do I fill in protons, electrons, and neutrons? Well, if we know the definition of the atomic number, we should wrote down earlier in our notes, same as protons. So if we go back up to atomic number equals the number of protons. So if my atomic number is 38, my protons would also be 38. Now, the other thing we have to know is that protons and electrons equal each other. And this was starred in your notes on the very first slide. Again, right here. Protons equal the number of electrons, which means if my protons was 38, my electrons would also have to be 38. And that brings us back to neutrons. Well, how do I find the number of neutrons? Again, neutrons is going to be mass number minus atomic number. Well, my mass number says it is 88. My atomic number says 38. So if you subtract those, strontium should be a difference of 50. Now, what if you were given different sets of numbers? Again, we can help fill these out. If my atomic number is 27, again, my atomic number and protons equal each other. So this is 27. Again, protons and electrons equal each other, so electrons also has to be 27. Now, how do I find mass number? So this is a new one. I have a blank. Mass number, remember, is protons plus neutrons. So if I take my protons, which is 27, and you add it to your neutrons, which is 25, you should get a mass number of 52. Now you have the element symbol is CO, and we have to figure out the element name. Well, we can look for CO on our periodic table, or we can look for this 27. I feel like the number is easier to find, so if we look at it, because it goes in increasing order, 27 CO is actually called cobalt. So we're going to fill in the name as cobalt. Again, if you are somebody, this table actually becomes a lot easier to fill out if you know that atomic number, protons, and electrons all equal. So we're actually going to do that real quick. Protons, electrons, and atomic number all equal. Again, electrons is 8. That means protons have to be 8. Same with atomic number. Again, these three always have to equal. So if that's 10, we have 10 and 10. If this is 35, electrons have to be 35, and so does atomic number. Again, 13 for electrons, that means protons have to be 13, and so does atomic number. So these three columns, again, they may not always be right next to each other, but they should be the easiest to fill out because they are all equal to one another. So that brings us to mass number column. Again, remember, mass number is protons plus neutrons. So if you wanted to solve for mass number, you would take protons, which is 3, neutrons, which is 4, and you get 7. Same thing down here, we're missing it. 35 plus 45. Again, if you have to use a calculator, please make sure you do that, which is 80. Here, again, mass number. Protons was 13, neutrons was 14, 27 is your mass number. And that brings us over here. Well, what about my neutrons? Remember, we put up here neutrons, mass number minus atomic number. So if my mass number was 16, my atomic number was 8, 16 minus 8 should give me 8 neutrons. Here, mass number was 20, atomic number was 10, 20 minus 10 gives me 10. That leaves symbols and names. Now, if they already have the name or the symbol, it's easy to look it up on the periodic table. For example, neon. If we look at the periodic table, neon is over here. Neon is Ne. So we're going to fill that in. Ne. And then we have aluminum. So we got Al. If you find Al on the periodic table, it's aluminum. If you look on your periodic table, it's going to call aluminium, but Al is aluminum. Oops, aluminum. But what do you do if it doesn't have a symbol or it doesn't have a name? Well, if we remember correctly, our atomic number identifies an element. So if my atomic number is 3, remember, that's never going to change. It's always going to be 3 for a specific element. So we just have to find the atomic number 3 and see who is it connected to. So again, it goes in order. We have 1, goes over here 2, and then we're going to find out 3 is Li, which is called lithium. Oops. So for atomic number 3, this is going to be Li, and this is lithium. We're going to do the same thing for this one down here. Notice my atomic number is 8, so we need to know who is number 8 on the periodic table. If we look below, again, it goes in order, so we have 4, 5, 6, 7. Here we have number 8. On number 8, we can see that its symbol is O, and that is oxygen. So we're going to fill in O, and this symbol is oxygen. So this is one way to kind of fill out this kind of chart, is again by knowing these different facts. Again, protons and neutrons make up your mass number. Your atomic number is the same as protons, and it's always found on the periodic table. Protons and electrons are equal to each other, and neutrons is mass number minus atomic number. I know that is a lot to understand, that is a lot to take in, so please make sure you really understand this information before moving on. And that's the end of today's lesson. Please let me know if you have any questions at all.